how do we get this B sine C? So if you look at this right angle triangle, you recall our sine rule. See this. Okay, if you recall our Tokaso, okay, no need sine rule because it's a right angle. So if you use Tokaso, our sine of C, okay, will be equals to opposite over hypotenuse. Okay, so we have to scroll back. Okay, equals to opposite over hypotenuse, which is B. Okay, so if I want to find this opposite side, I multiply B over, I will get this B sine C. Okay, not to be confused. So once we found this entire length is B sine C, we compare it with this side C that is given. If it is longer, okay, if this perpendicular is longer, this opposite perpendicular is longer than the length of C that is given, okay, we will not have any triangle. Okay, if you are still confused with this with figure 1, let's go back to look at figure 1. Okay, based on the previous video, I explained in figure 1, same situation, B is longer than C, and we are also given angle C. Okay, and how come in that situation we have ambiguous case? Okay, because the length C given, alright, is actually longer than this perpendicular. Okay, this opposite side that we have calculated here. Okay, B sine C, this length. Alright, so therefore we are able to form triangle. So in this case, this length of C that is given, right, is shorter than this whole perpendicular length. That's why we can't form a triangle with this angle C over here. Okay, that gives us this angle size of C over here. Okay, let's look at figure 1. Okay, figure 1. Alright, if I drop a perpendicular down, okay, we make use of the same concept. If I want to find this length of this perpendicular line, okay, we use Tokaso. Alright, sine C and hypotenuse is B. So sine C equals to this opposite, okay, this opposite length over B. B is our hypotenuse. So if we want to find opposite, okay, we multiply B over this length is B sine C. Okay, so if the length C given is longer than B sine C, we can form an enclosed triangle that preserves the size of this angle that is given in our question. Okay, so add in one more condition, B greater than C. Alright, angle, okay, first question give us two lengths, BC and angle C that is opposite of one of the length that is given. Okay, and between these two lengths given, this angle C is opposite of the shorter length. Okay, and for this next thing, whether it can form an enclosed triangle that keep this size of angle C that is given, alright, we compare the length C with this perpendicular B sine C. Okay, so in short, in summary, right, we have it here that is being typed out. Okay, so this one correspond in A ambiguous case, this one corresponds to figure 1. Okay, description in figure 1. We have two lengths given, okay, and then two possible triangle can be formed. Okay, the side opposite the given angle is the smaller side that is given. Alright, and longer than the perpendicular. Okay, perpendicular is our B sine C. Alright, and for B down here, there is no ambiguity, there is only one triangle that is formed. Okay, there is only one triangle that can be formed. Remember the right angle. Okay, if we find angle ABC, right, this angle here, it gives us 90 degrees. This is angle C. Okay, so C. Alright, C is shorter than B that is given, and yet when we find this angle here ABC, it gives us 90 degrees. So there is no room for ambiguity. And another possible situation, figure 3, this one corresponds to figure 3. Okay, where C is longer than B. If C is longer than B, alright, if the question gives us a longer value of C than B, okay, this one should be small. with this angle here, there can only be one fixed triangle. Alright, for more explanation, you may want to look back at figure 3. Okay, and next, this one corresponds to figure 4. Okay, no solution. You can't even form a triangle with the values given. Okay, with this angle that is given, because the length of C is too short. Too short meaning if I compare it to the perpendicular, okay, B sine C, the opposite, is too short. Alright, let's look at example question now. Okay, example 11. Alright, this question here doesn't give any diagram. Alright, this diagram, this triangle is put in by myself, just in case if we need it later on in my explanation. Alright, in a perfect scenario, if you have mastered this well enough, you wouldn't need to even draw any sketch or what of a triangle. Okay, let's look at the information given. We have a triangle. We have triangle ABC. You have angle ABC equals to 48. So one angle is given. Okay, and the question gives us two sides, AB and AC. Okay, so now what we can do is we need to check whether the shorter side is opposite of this 48 degrees. Okay, if it is opposite, we have a very high chance that this is an ambiguous case. So when we find some of the angles inside here, there should be more than one answer, because a triangle can take more than one possible shape, possible form. Okay, so we just label in accordingly A, B, C. So AB is 15, AC is 13. And what is this side? ABC. Okay, let's see. This angle, angle ABC is here, 48. Okay, so in this case, 48 is opposite 13, which is the shorter side. So we should consider ambiguity here. Okay, if you recall, whether this will there be problem with this question? Will it give us a so-called no triangle, like your figure 4 on top? Okay, we can do a check. Okay, recall the checking so-called trigo formula is B sine C. Okay, recall B sine C. Okay, where we try to find opposite, so-called opposite side. So we find what is this value and then we compare to 13. Okay, 13 should be longer than this in order for the triangle to be able to be formed. So what do we put in here as our B sine C? Okay, so in this situation, this angle here is given. So this angle is actually our so-called C. Okay, this is our side C. So this one has to be B. So we use 15 sine of 48 degrees. Okay, so on our calculator, we will get 11.147. So this is not an actual calculation, just a check. This is just a checking, alright, of whether this is anything wrong with this question. But it is very, very extremely rare that question give you a situation of figure 4. But it's always good to just press on the calculator to check. So 11 is smaller than 13. So this length that is given is actually longer than this B sine C. So yes, we can do some calculation, meaningful calculation, because triangle can be formed. Okay, so we can go about calculate our. We are supposed to find 3 things. Okay. All right. So if we look at this, the sketch here, we will see that this length 13, okay, is possible to be to form another triangle. Okay. So this point C, we can have 2 different triangles. So length, the angle ACB, we can have 2 possible values. Okay, ACB we have 2 possible values. Remember the values that are given, right? We have to fix. We can't change it. Okay, so we can double check. All right, if we look at ACB, angle ACB, okay, we can have 1 value here, and we can have a bigger angle ACB. So it's possible ACB we have 2 values. Alright, and then if we look at this angle BAC, ACB, okay, and BAC, alright, we also can have 2 values. Okay, BAC we can have 2 values, 1. Okay, angle ACB we can have 2 values, 1 here, the other one here. Okay, and the length of BC definitely we can also have 2 values. okay, based on what is given here. Alright, so we go according to the question. Okay, let's calculate what is angle ACB first, okay, which is this one. Okay, angle ACB, we can use sine rule since 13 and 48 is given, they are opposite. So 13 over sine 48 degrees, okay, we will get 15 over sine of angle ACB. Okay, if you want us to find ACB, so we can do a little bit of shifting values around. Okay, 15 divided by sine 48. So to find angle ACB, we use inverse sine. Alright, and on calculator we can get the value. Okay, this should be 13 divided by sine 48. Alright, 13 divided by sine 48. We get inverse sine of 0.85747. Okay, so if you can recall the sign of obtuse angle, any ratio that is given, alright, will give us two possible angle value here. So ACB, okay, this directly can give us two possible value of your angle ACB. Okay, if you need more explanation of why can give two value, I will attach another video after this. Alright, to explain why you can get two separate values here. So we do our inverse sine to get 59.0342 degrees. So round off to one decimal place, 59.0 degrees. Okay, so for the other possible value of angle ACB, okay, we can use 180 degrees subtract. Okay, so we will get 120.965 degrees. So if we round off to 3SF, okay, we will get 121 degrees, okay, to one decimal place. Alright, so we can actually after that calculate the angle BAC and the length of BC using these two separate values, because recall we can have two different triangles being formed given this set of values here. So one of them will be when angle ACB is 59, another one will be when angle ACB is 1 to 1. Okay, so I'm going to do this on the next page. Okay, recall we have two values, angle ACB, alright, is 59 degrees. Okay, and the other situation, angle ACB is 1 to 1 degrees. So we do our corresponding calculation here for the other angle and the other side. Okay, based on angle sum of triangle is 180 degrees. Okay, I subtract ACB and 48 is given. Subtract ACB, 48 is given, so I get the two values of my angle BAC. Okay, based on angle sum of triangle. Okay. And next we are supposed to find the length of BC. So in order to find BC, we can use sine rule. We can use the two values of my angle ACB here. It is opposite the side BC. Okay, so I use the sine rule, right, and I can get two values of BC. Okay, so this set of values of my ACB, BAC, and BC, okay, will form one possible triangle, and the other set will form another possible triangle given the values that the question have given us. Okay, so it doesn't matter if right now all the calculation doesn't fit the sketch of the diagram that I have drawn. Alright, okay, the diagram is just to provide some guidance as to how we can approach the question, okay, and to check the ambiguity. Okay, so if you need more explanation, back at this part, how come when I inverse sine, it gives me two possible answers. Alright, do check the additional video part 3 that I will upload as well.